Major support for Do the Math has been provided by Chevron, California Resources Corporation, Edison International, Center for Neural Skills, the Kern County Superintendent of Schools, Kern High School District, Panama Buena Vista Union School District, Tuolumne County Superintendent of Schools, and Valley Strong Credit Union, with additional production assistance provided by these supporters of education.
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Cece.
And I'm Bo. For math homework help, call in Bakersfield 636-4357. Anywhere else, call 1-866-636-6284. Email is dothemath@kern.org. We're online at dothemathonline.net and social media.
A lot of sixes in those phone numbers, aren't there? Mm-hmm. Are you in sixth grade?
Yeah.
That's pretty good then. All right, so it all works out today. So, Bo, where do you go to school?
Patriot.
Patriot? And does that school end at sixth grade or does it keep going?
It ends at sixth grade.
It ends at sixth grade. So do you know where you'll be going to school next year?
Freedom Middle School, where my sister is.
Okay. And your sister enjoys Freedom Middle School pretty well so far?
Yeah.
Are you guys going to be there at the same time or is she moving on to high school?
She's leaving the year I'm getting there.
So you're going to have the place to yourself? Mm-hmm. All right, good. So is there anything you're looking forward to as far as junior high goes?
No.
Just going to take
Learning new stuff.
Yeah, there you go. Well, you ready to learn some new stuff today?
Yeah.
All right, we're going to get right to it then, all right? Mm-hmm. So let's take a look at today's social media problem of the day, and here it is up here. So can you read that for us, please?
Convert the given measurement in the new correct units. 5 feet, A is 58 centimeters, B is 2 yards, D is 150 centimeters, and C is 60 inches.
All right, so we've got metric and customary units up there. We've got centimeters, yards, and inches, and feet. Mm-hmm. So when we see 5 feet up there, when you think about that, what's the first thing you think of as far as converting it to other units?
So 3 feet is 1 yard and 12 inches is 1 foot.
Okay, so that's good stuff to know, right? You know there's 12 inches in a foot, 3 feet in a yard.
Yeah.
But we have 5 feet.
So 5 would be, for 2 yards, it would have to be 2 times 6 because 3 feet are in a yard, so that one can't be it.
Okay.
I'm going through the not metric units first because I don't know how to do that really. So then 60 inches. So 5 divided by 60, you go 5 divided by 6 would be 1. You carry 5 minus 6 is 1, and then you carry down the 0. So it's 10, or 5 divided by 10. And 5 divided by 10 is 2. So then 12 feet, or 12 inches would be what, 5 feet. So then we double check it. 5 times 12 is 5 times 2 is 0, and then carry the 1. 5 times 1 is 5, plus the 1 is 60, so it's C.
So you think it's C?
Yeah.
Well, that's pretty good. I mean, there was a lot of stuff going on in your head right there and explaining it all, and you did it beautifully right there. So now hold on, bro. You ain't getting no fist bump. Yeah, we don't know if you're right yet. So do you think it could be one of the centimeters ones? Because can we change feet into inches and then inches into centimeters? Is that even possible?
Yes, but I don't know how to do it. I don't think it is.
It is possible, right? Because have you ever seen a rule, right? And it's got 12 inches on one side and then it's got centimeters and stuff on the other side, right? So it is possible to do it, but that conversion's a little bit more difficult, isn't it? So you feeling good about 5 feet is equal to 60 inches, C?
Yes.
All right, let's take a look and see if indeed you are correct. There you go, dude. Now we'll do the fist bump. Now, first problem done, all right? There you go. 636-4357 is that phone number. We do have phone tutors available most Tuesdays and Wednesdays throughout the regular school year. Time now for today's Math in the News. All right, joining us today we have Albert, and Albert is with InnovaMath Education. Albert, thank you very much for joining us on Do the Math today.
Thank you so much. It's an honor.
Thanks for having me.
I'm glad that we were able to finally reach each other once again, because I remember when you first were in Kern County, as soon as I saw your presentation, I knew I had to use InnovaMath in my classroom, have been, and I knew that we needed to let other people know about it. So kind of quickly, we're going to talk about what InnovaMath is as we kind of go through the website a little bit right now.
We're all about thinking, and thinking in the classroom. That's for us. What is a success class? There's a lot of work that we do on the mathematical practices, like what is beyond content. Content needs to be taught, but what is beyond content? And it's about these skills that are more about thinking and reasoning and establishing connections. And yeah, we claim that we are an all-in-one math partner, of course, all-in-one, but in the math domain, because that's all we do. And maybe later we can dive a little deeper into our approach, but we only do math, and that's our commitment and our focus. And we're 300 people in several countries only doing math and working with schools, partnering with schools, and working on this journey together.
So I like everything that InnovaMath does, and I saw one of the parts in there was the family engagement, because you want the family to be working with the students as well, which I think is a big part of kids thinking about math, and also having the people in their family help them with it and see how they can grow at the same time as well.
Yeah, and it resonates with what you do, right? This is community building, and we're not changing things only one class at a time. We need to go, of course, student by student, but trying to engage everyone on this endeavor, right? And families are a key piece in child education. So yeah, it's about community. So it's not rare to find us going to a school to do a family night. We have fun with parents as much as we do with teachers and students.
Yeah, and I think that's a great attitude to have, and exactly what you want InnovaMath doing, interacting with the families at the schools and the kids. So one of the things that I love about InnovaMath are the games and activities that you do with the kids, and things to get them into lessons and then to culminate a lesson also. And this is the Notice and Wonder one, where the first thing I know, because what I like about this also is that there aren't directions up there right away.
That's like, okay, what do you notice? What do you wonder, right? We were at the NCTM conference this past week, and that's how we approach the activities. Like some visuals, something to spark the conversation, and then, hey, what do you notice? What do you wonder? And here we could say, oh, I see some numbers, some shapes, right? And we could start talking about these numbers and these shapes, circles, rectangles, hexagons. And this vocabulary sparks naturally. And then we start, when we have this conversation and the ground is set, we can move on to the statement and say, okay, this is the task that we're facing. And in this case, I don't know if you've ever faced this. Probably since you've been finding us many times, Mike, you have seen this before. But what do you notice? What do you wonder? You wanna do it right, like super quick with me?
Sure, let's go ahead and do it. So
okay,
when I look at that, what I notice is that I've got two different numbers, and they're both double-digit numbers, and I wonder, why is one in a bigger circle than the smaller circle? Obviously, I would think the bigger circle has the bigger number, smaller circle with the smaller number. But then when I look to the right of that and I see the 120, I'm thinking, well, the 120 is underneath the two circles that are blank, so the 120 must have something to do with the two circles on top.
Very good. And this allows me, of course, if you were a student, this allows me to say, okay, where are the eyes, right? Where is the conversation going? So here's the thing. The only rule that we have to keep in mind here is that within the rectangle, we have the addition of the two previous numbers. So of the two numbers in the previous row. And in the hexagon, we have the difference between those numbers. And we could start thinking, and probably there's some people home trying to start thinking, right? And we can do this together, maybe 75 plus 36, right? This is...
So we've got 111.
111. Okay, we have 111 on the left, on the rectangle, and then the difference would be
39.
And 39, and a conversation on how do you know and all this, and how did you solve it, and talk about strategies would be wonderful. Probably not now the time, but it would be wonderful in the class, right? So we have 111 and 39.
All right, and then I think on the next slide, we've got where you can see another problem like this. But then once we get to all of those, at the end of this whole thing, we can see how these things are all solved, where you've got it spelled out like that. And I think that's one of the beautiful parts about the InnovaMath is that you go through all of these different things, and then you can see the culminating activity and how to solve it right then and there.
And it was only a glimpse of activities along all the journey, right? This is not one day, one activity, right? We're seeing this activity, and this is about pattern seeking, right? So you have an excuse to do some operations, but then you're trying to seek patterns, you're trying to reason, you're trying to think. And when we design activities, when we try to create the instructional materials, we have that in mind all the time. Are we sparking thinking? Are we sparking reasoning? If yes, then we go. If no, we then try to redesign to do it better.
Right, and I think that's another part that you guys have a lot of success with is the spiraling approach. And if you could briefly tell us a little bit about that also.
Yeah, so the people is surprised the first time they see our core curriculum design because we don't follow units, right? And at the end of the day, every curriculum, every program, even the standards in any state in the US follow some sort of spiral. You do addition in first grade, but then you have standards about addition in second grade and in third grade again. So it's a spiral. It comes back, right? But traditional math does things in silos, right? And puts things in silos in general. Of course, there is many different approaches to math. But the most extended traditional one is units. So unit 1, addition, maybe subtraction. Unit 2, fractions. Unit 3, and then at the end, unit 12, unit 13, geometry, probability, which are typically the 2 units that teachers don't have time to do because summer arrives and we have to stop and then go to the next year and we start over. So instead of going full units, what we designed and what we follow is a spiral approach, which is not our invention. There is many people claiming that it's better to do a spiral approach. And basically what we do is break down the units. So one day you might be doing addition, the next day again, if that's needed. But then the third day you might be doing some geometry that helps you understand addition and helps you foster these connections. And then the fourth day, you might be going to another topic, maybe statistics, and use some of the things that you learned in addition to apply those in statistics. And then you go back to addition. So we go back and forth. There is no silos and no units.
And that's the key.
As a web.
That's the key, Albert, I think, is the connections right there by using that spiral approach. So anyway, Albert, the head of learning in the United States, and I'm sure we're going to see Innovamat a lot more places because I certainly love it and hopefully a lot more people will love it also. Innovamat.com is the place to go to find out more. We'll be back with more right after this.
Thank you.
Our mathematician today is a French lady, Sophie Germain. Her parents disapproved of her doing math because they wanted her to go to school and learn other things that most women did during that time. So what they did is they turned off the heat to her room, removed all the lighting, and they decided that that was going to keep her from studying. Therefore, she'd be cold and in the dark. She smuggled candles in during the day, and that way she would study at night, put a comforter around her, and that's what she did. She devoted herself to this problem that Archimedes had died trying to solve. At 18, she would send in work to different universities, and she would have to sign it as a male, Monsieur Leblanc. Now, Sophie wrote a lot of different things about mathematics and was highly acclaimed as Monsieur Leblanc, and won acclaim later in her life once they figured out who she was. But she worked with number theory a lot. Number theory is a fascinating branch of mathematics which studies the properties of counting numbers. So this is how we find out what are called happy numbers. So this is something that Sophie was looking into number theory quite a bit. And we're going to see, is 19 a happy number? So what you have to do is you have to compute the sum of the squares of the digits 1 and 9. So if we take 1 squared, we know that's 1. 9, the other digit in 19. 9 squared is 81. So you add the two of them together. 1 plus 81 is 82. Now, if the result is 1, you stop, right? You repeat the process. 82 is not. So now what we're going to do is we're going to take 82. 8 squared is 64. 2 squared is 4, we have 68. Well, it's not 1. So we're going to take 68. 6 squared, 36. 8 squared, 64. You take 36 and 64, you've got 100. Now, a lot of students might be going, hey, you know what, that's part of the Pythagorean theorem right there, but that's another story. So anyway, we're now at 100. So we have 1, 0, and 0. Obviously, 0 squared is going to be 0. 1 squared is always 1. The result is 1, so 19 is what they classify as a happy number. So just one little thing in number theory right there. So we'll take a look at another one, 11. So let's start with ones. 1 squared and 1 squared is 1 plus 1 is 2. Well, we have to take 2 and square it, is 4. 4 squared is 16. 1 plus 6, we can see, is 1 plus 36. 37, you keep on going all the way down the line, we've returned to 4. And if you remember in other mathematicians that we've done, 4 is a key number as far as having things continue in a loop, what sometimes they call Hale numbers, right? That, because they constantly are going up and down, you're never going to come to the end because they're in that continuous loop. So 11 is not a happy number. So there are a lot of other numbers that you can always try this out with. That's one thing that Sophie did, and that was to work with number theory, and that is our mathematician of the day.
Did you know that the number of ways to shuffle a deck of cards is 52 factorials? The number is greater than the number of seconds that have happened since the Big Bang. That's a lot of possible ways. A factorial is a number that is multiplied by every number lesser than itself. For example, 3 factorial is 3 times 2 times 1. Now you know.
All right, in studio we have Bo, a 6th grade student from Patriot Elementary. Now, did you know about factorials? Had you ever seen that before, that exclamation mark in mathematics? That went right by you, didn't it? Mm-hmm. All right, it's all right. So factorial is something brand new. So you're going to see that when you get into junior high and high school, all right? But in Novamat, Albert, who we were talking to a little bit earlier, he is working with the Novamat, and they've got a wonderful series of math books that they've got, and you're going to do one of the math problems right now. You ready for it?
Yep.
All right, head on over to the board. You and Cece are going to tackle this, and you're going to do a little division. That's the only hint I'll give you, okay? All right, go to it.
We're going to do division. We're going to do a lot of other things too. But okay, so if we read this, you want to go ahead and read our instructions?
If we know the distance between the first and second flag is the same distance between the second and the third flag, at what kilometer is each flag on? Fill in the numbers for each kilometer with cards that are the same color as the corresponding flag.
Okay, so I see my green one is 312. And then I know that we've got 645 right here. So we know, can we figure out the distance here?
Yes.
Well, how would we do that?
By subtracting 312 by 645.
I love it. Would you go ahead and do that for me? And you can come over here and do that.
So 5 minus 2 is 3, 4 minus 1 is 3, and 6 minus 3 is also 3. So
Oh, fantastic. Okay, wonderful. So if we know that the distance from here, from our green flag to our red flag is 333, where do you think this lands right here? What number is that going to get?
645 plus 333.
Okay, let's figure out what that is. Will you go ahead and do that for me?
Three plus 5 is 8. 3 plus 4 is 7, and 3 plus 6 is 9. So
Okay, so 978. So, and we noticed that our blue flag had the numbers 978. So that's what we're going to be doing here. So, okay, so great. That was a good practice for that one. Okay, so what about if I'm going to go to figure out what my green flag is? What am I going to do?
you could subtract 465 by 798.
Okay, so we're going to take that 798. We're going to subtract the 465. And we'll see how far away our red flag is from our blue.
8 minus 5 is 3. 9 minus 6 is also 3, and 7 minus 4 is, again, 3.
Ah, they're exactly the same. Okay, so we know that this is 3 through 3. So I'm wondering if it's going to stay the same every time, but let's go ahead and figure out what our green is going to be then. Now that our center, our red flag, is 465.
I would subtract 333 from 465
I love
because you're
it.
going backwards.
Absolutely, that's fantastic.
5 minus 3 is 2. 6 minus 3 is 3. And 4 minus 3 is 1. So it's
Great.
132.
132. So we know 132. We have those colored. That's part of our green. So we'll say 132. Okay, so that kind of helps us to make sure that we're getting our right numbers, because if our numbers weren't there, we would be in trouble. Okay, very good. So that looks like we're kind of going along. What do you think was going to happen here?
You could subtract 231 from 897.
Okay. Why don't you do that and we'll see what happens.
7 minus 1 is 6, 9 minus 3 is 6, and 8 minus 7 is, wait, is that 7? No, it's 2. 8 minus 2 is 6.
Okay, good. So we know again that from here, from our green flag, all the way to the blue is 666.
But
Go ahead.
they are one number apart. So if it were to be from there to there, maybe it would be 333 plus that to get there. So it
I
would be
love it. Okay, so go ahead and tell me what we're going to get for our red flags then.
231 plus 333 would be 3 plus 1 is 4, 3 plus 3 is 6, and 3 plus 2 is 5. So it would be 564.
Okay, and then we'll check. We have a 5, we have a 6, and we have a 4. So very good. Okay, so it looks like it's 333 away every single time.
Yeah, and I
So-
think you guys have got the thing now. You see
Yeah.
that there's 333. How about you jump to F
Okay,
and see if you can figure that out?
so what do we think?
So 564, and each one is 333 away from it.
Good.
To figure out this one, we would have to add it.
I love
and
it.
To figure out this one, we'd have to subtract
I
333.
love it. Okay,
Can
go
you
ahead.
do either of those in your head?
Yes.
Go for it.
So subtracting would be minus 3 is 1. 3
Go
minus
ahead and you can write it in as you go. So no. Just go ahead and tell us what our numbers are.
3 minus 4 is 1. 3 minus 5 is 2. And then 3 minus 6 is 3. And
Okay.
we have a 3, a 2, and a 1.
Good.
And over here, 4 plus 3 is 7. 5 plus 3 is 8. And 6 plus 3 is 9. And we can
Good.
check again by seeing we have 9, 7, and 8.
Nice. Perfect. Okay, I like that.
Yeah, nicely done. So that's only the first page. Let's go to the next page.
All right, page.
So you'll have to
number
erase
2.
some of that stuff there,
Okay.
CC. There you go.
Go ahead. You erase that side. I'll erase this side. And there we go. We are on our way onto this next page. Okay, so I don't know. I think our 333s are over. Let's figure out what we've got next.
So from 50 kilometers to 70 kilometers would be a 20 gap distance.
I love that.
Because 50 minus 70 is 20.
Yeah, so the 70 minus the 50, so we were going backwards. So the 70 minus the 50 gives us our positive 20. Good,
Yeah.
okay.
And then, which if it's going by the same pattern, it would be 70 plus 20. So plus 20,
Lovely.
which would equal 90.
I love it. Fantastic. Okay, so let's keep going. So now I don't think we have our same spacing here. What do we have?
We have 90 and then 120. So again, you could subtract 90 from 120,
Perfect.
which what I would do for this one is I would just take away the O's. 9 minus 12 is
Okay.
3, and then add the 0 back.
I love that. That's a good skill.
So it's a 30 gap distance. And to figure out what this one would be, we would subtract 30 from 90,
Yeah.
which again, you could just get rid of the zeros, and that would be 6D.
Okay, fantastic. So we go ahead and label that one, and we know that's 60.
Nicely done. So you know what we're going to do? I think you got the idea of that page. So we're going to go to the final page, and you're going to work on some of those now.
Okay, and I'll erase this here. Okay, so this is it, our last page. Oh, thank you so much. Okay,
And the green flags, and then the one is the same distance.
so we've got that same distance again. So what are we thinking for part A?
So you would, if it's the same one again, 432, you could subtract it from 500 to get what the gap would be. That's about 3. And then it would be, to get rid of that one, 4, this one becomes 9, and this one becomes 10.
Perfect.
So it would be 860.
And I think that was a 4.
Yeah, that's 4, 8, just 68.
Okay, nice.
So then you would add,
Oh yeah, let's figure out what we're adding it to. Okay.
68 to 500,
Uh-huh.
which I can do in my head.
Perfect.
568.
There you go, nicely done. So I just wanted you to sample a little bit of each of those different pages. Come on over here. So as you were working through those problems with Cece, did you see anything that you noticed?
There was always a pattern between like each of them.
Dude, I'm telling you right now, you just hit the word right on the head right there. So all I wanted you to do was say the word pattern. You came out with it right there, right? Because all mathematics is patterns, right? And if you're able to find those patterns, you can solve problems a lot easier. And as you get into higher mathematics, if you can find those patterns, they're going to be more difficult to find. But that's all it is patterns. So nicely done. So for some great work today, you've got yourself a meal courtesy of our friends at Chick-fil-A. So congratulations on that. And you said you like the sandwich a little more than the nuggets?
Yeah.
So do I. That stuff is good. You like that stuff?
Yeah.
So do I. Cece, you like that Chick-fil-A?
Oh, yeah, for sure.
Who doesn't? We'll be back with more right after this. Well, today we're at Creston Sawmill in beautiful Creston, I might add. And Cam, you are the owner-operator, correct?
Correct.
All right. So how long have you been working with wood?
I got into this industry by accident. I had a friend of mine that had done some milling up north, helped him with a project, and I took interest in it. And then I bought this place and it had a bunch of dead standing timber on it. And I thought I ought to do something with it. So I started off with a small Alaskan chainsaw mill, also known as a Granberg mill. The more I worked with my hands in wood, the more I got into it. Like they say, gardeners, they like working with their hands in the dirt. It's a similar type deal. And I grew to liking it.
Well, you can see you got something set up here. So basically, where do you get most of your wood from?
Most of my wood comes out of Santa Cruz Mountains, primarily Boulder Creek. These logs here with the burnt on them are out of the China Grade just outside of Boulder Creek from the big complex fire they had up there in 2020 that burned all the way to the beach. There's plenty of redwood up there. I do get some logs out of Felton. I can get pine and cedar out of North Fork up there out of Coarse Gold. So most of it's just half a day away. So it's not that big a ordeal to bring them in. I've got my own log truck, so I bring them in when I see fit.
And you've got a variety of wood, it sounds like also. Well, we've got something set up here, so let's start cleaning this up.
Okay, what we're cutting today is redwood log that I pre-cut it a little bit because it was so large that I had to actually chainsaw mill this one down so it would fit in the band mill. And this log I think is about 10 foot 4 inches right now. I'm cutting a bunch of horizontal fencing right now, and it totals for 3,000 board feet. And board feet is a volumetric measure of lumber or wood. When we get the logs, we measure them on the small end, the diameter, and then you use this handy little Scribner's book, and you take the diameter and the length, and they'll tell you how many board feet are in that log and what you can expect to get out of it. And the reason you measure off the small end is because logs have taper, or in this case, this was the butt cut, so it has a lot of swell down at that end where it went to the stump. And so that is what you're insured to get out of it, assuming there's no defects or hidden wire, electrical wire, insulators, because a lot of people in Santa Cruz Mountains run wires into trees to get to a little cabin in a ravine somewhere or whatnot. So we run into a lot of foreign material. You look over there on the tongue of that trailer, you see some glass insulators I run into, and they damage the blades immediately. This log here, assuming this was still around, this is hypothetical, and we take a measurement off the small end, and we got 24 inches. So if we got 24 inches in diameter, and we come on down here to 10 foot, this log's gonna yield 250 board foot.
So you're gonna get 250 board foot out of this?
Out of what you see right there.
And we just need to clean this top off right now.
We gotta clean this up, and then we'll cut it into a 12-inch cant and slice it off, just like bread, into 12-inch wide boards there. Now, a board foot is a measurement of 12-inch by 12-inch by 1 inch thick. So each one of these boards, since they're 12 inches wide and 7/8 thick, plus the kerf, which is 100 thousandths, which almost makes us 1 inch by less than 25 thousandths. So we can consider the kerf and the material to be consuming 1 board foot. So times 10, there's 10 board foot for one of those. So hypothetically, since this is 250 board foot, we'll get 25 of those boards out of this log. But since it's not a 24-inch square where you get two cans of 12 out of it, we're gonna be making some 6-inch boards also, which are obviously half the board foot, and the fence pattern is going to be alternating, where they're horizontal fencing where there'll be a 12-inch and a pair of 6s, and the variety is going to be all the different patterns created by the sapwood to the heartwood and the different width of the boards. So,
Oh, good. We've got all of the math kind of falling into place here.
Right.
So when we come back, we're going to go ahead and start cutting and get some board foot out of this.
right.
All right, we'll do that next. All right, well, we've got Bo, a 6th grade student from Patriot Elementary, in studio with us. And what's up with the rubber ducks? You like rubber duckies?
Yeah.
They're pretty cool. You know who else likes rubber ducks? One of our producers, Mac. She's all over the rubber ducks. I'm sure all of our producers are into rubber duckies.
Oh, I was thinking you were going to talk about Ernie, but
Bert and Ernie?
yeah.
They had that little song, Rubber Ducky or whatever.
I would sing it, but my voice, well,
Yeah,
Rubber Ducky, you're the one.
We'll release you on that one right now. Do you know who lived in the basement at the house on Sesame Street? Because we know Oscar lived
He's out in
outside,
the
right?
trash can, yeah.
Do you know who lived in the basement? Because in city structures, right, you've got a couple of floors,
Yeah.
people live on different floors, and you can also live in the basement also.
No.
Bert and Ernie.
Oh, they
lived in the basement. Anyway, you ever seen Sesame Street?
Yeah, a little bit, but I don't really watch it that much.
Yeah, I don't watch it that much either anymore. So. You ready to do a math problem?
Yeah.
All right, head on over to the board. Read that to CC, see if you guys can figure it out.
You have 5 bags of coins. Each has one kind of coin. The bags have coins worth 1, 3, 5, 7, and 9. If you can, find 10 coins that add up to 43. If you can't, describe why it's impossible. Which numbers are possible?
Okay, so we don't have our normal coins. We have ones that are worth 1, 3, 5, 7, 9. Okay, we need 10 coins that are going to take us to 43 cents. Grab a pen and let's start playing. What do you want to do?
So, starting off, I'm trying to figure out what would get close to 43.
Okay.
So then you could finish it off with ones.
Ooh, I like that. Okay, good. That's a nice idea.
All right. I have kind of an idea, but it's not. So 7
Okay.
would be the one, because 7 times 7 is 49.
Okay,
7 times 6 is 42.
okay.
So maybe 7 times 5 being 35, you could find something else to add up.
Okay, so look at that. We'll give that a try. Okay, so we've got 5 7s.
5 times 7 is 35 so far.
Okay, and we've used 5 coins, so we need 5 more coins that'll get us to 43. Okay.
Maybe 3s, I'm thinking.
Okay.
So 3, we have 5 coins left, and 3 times 3 is, I'm just gonna try the.
Sure. Go ahead.
So 3 times 3 is 9, so adding 9 to that would give us 14, and then
Oh, not multiplying.
no.
Let's just add. It's all right. You can erase that.
14, and
There you go.
then, wait, no, that 44.
Okay.
So then that would be 3.
Wah, wah, we're over. We need to add up to 43.
So then times 2, which would,
Okay.
times 2 is 35 times 6
Okay.
is 11, which would be 41.
Okay. So now we've used 7 coins. Okay.
But that wouldn't end up being able to work, because then the rest of them would add up with ones, but that would end up being 44.
Yeah. Yeah. Okay. All right. But that's okay. That's a good way to get started.
Close.
So what else could we try instead? Maybe.
Maybe with adding 5s. Can I erase this?
Sure. Absolutely. You race away. So you're gonna skip the 7s and just go to 5s?
Try with the 5s or the 9s.
Okay.
So with 5, if you get 7, 5, well, no, that would be the same as last time.
Well, but we would have used 7 of them at least. If we did with 5s, if we used 7 5s.
7 times 5 is 35.
Okay, so now we have 3 coins left.
Maybe a 9 would get it 2, 4, 1, would get it over. So we can't add 9 at all.
Yep, we can't use 9s. Okay. But if we, what else could we use? We've got 3 coins left.
We could maybe use a 7.
Okay, if we use a 7.
It would get us to 12. It would get us to 42. Which
Bummer. Okay, because we got 2 coins left, so that would get us back to the 44 again.
Yep.
Okay, so that's not working so great.
if you were to add another 5, it would make it 8, which we would end up going over.
Okay, so if we had 8, 5, oh, well, that would get us to, oh yeah, because that would get us to 40, and then we would get to get to 42. Uh-oh.
You're always a penny off.
I know, we are struggling here just a little bit. You know what, I think that we might be struggling because of the fact that we have all these odd numbers, we don't have any evens maybe. Maybe that's our problem.
Right, so take a look at the question. It says, if you can't, because you're not able to find a solution for 43 yet, right? So it says, if you can't, describe why it's impossible. Why can you not find an answer for 43 so far?
We're not.
Why do you think?
Because all of the numbers are odd and like all of them are odd numbers and like hard to.
So that might
add to
have
it.
something to do with it, right? So that's part of why I wanted you to do this type of problem, right? Because it's not straightforward. You're not going to be able to get it right away. Mm-hmm. And for all I know, you might be able to come up with a solution. But right now, you could look at it and go, 43 is not easily attainable. And it could be because all those numbers are odd. Mm-hmm. So anyway, you did some nice work on that. Maybe we'll get back to that a little bit later on. But remember how Cam at the sawmill was talking about one board foot, a 12 by 12? Well, that's what we've got. We were able to bring this back from Creston Sawmill at 1 by 1, and we're going to find out a little bit more about that right now. And once again, we've got Cam at Creston Sawmill, and we were speaking a little bit about board foot, and this is an actual board foot.
Board foot, yeah. Board foot is 12 inch by 12 inch by 1 inch thick. This one's a little thinner because it's been planed for installation at home as paneling. But this gives you a visual representation of what board foot is. So, you know, if you had 10 of these, you'd be making one of those. So each one of those fence boards over there is 10 board foot.
Because when students, they go out and they go to a lumber yard or a home repair place or whatever to get supplies, they're going to see board foot. And this is what they need to understand.
Right.
And fencing is eventually what we're going to be doing here.
Correct. This is horizontal redwood fencing.
What is the next step now?
The next step now is I've squared up 2 sides of this log because it was a problem log being too big for the mill. So I had did some preliminary work here. But the first thing we're going to do is square up this to continue making it into a cant. Now a cant is basically just a log with the 4 round sides taken off it. And from the cant, you break it down into whatever you want. So in this case, we'll get this down to a cant. We'll take this side off. I will square it up so that this side is perpendicular to the mill bed. I may have to shim it and make a cut. So then when I'm done with the top cut, these 2 sides on the top will all be 9 degrees of each other. Then we'll roll the log over and correct the bottom, because the bottom was chainsaw milled because it was too big to fit in there, and it's very irregular. Chainsaw milling is not very precise. And I just blew through it real quick so that it would fit and we could, carry on with the band mill, because this has a lot less kerf, a lot less waste. So this blade will take out 100 thousandths, whereas the chainsaw is taking out 420 thousandths. So it's 4 times the waste.
So tell us a little bit about the blade that you've got.
This is a carbide blade. The hardwoods do a lot better with the carbide blades because the hardwoods dull the blade a lot quicker. Having a carbide blade or a brand new steel blade will ensure that we get through here minus any foreign material that might be in there. There might be nails, there might be glass insulators, but if you're doing really dirty logs or hardwoods or stuff that has fencing and stuff in it or screws, you're gonna go through a box of blades every day or 2.
You ready? Let's cut.
I'm ready.
All right. got this pretty much set. So in the last segment now, we're going to start getting to the boards.
Right, we're gonna make one more cut on here, and then I will take some measurements on it to make sure everything's true and good the way I want it. And then the next thing we'll do is we'll look at the log, or excuse me, the cant, and identify any defects. Like say this log, or when it came in here, had let's say it had a big logging scar in it, or it had a really bad heart check, which is like this one here is running diagonally, so it's shoot me in the foot here. But if it went horizontal or perpendicular, I could cut so that when I mill the lumber, that whole defect would be in one little thin strip that I could discard.
All right,
so
well,
that
we're gonna
defect
do that
wouldn't be in
next.
everything. So yeah.
We'll deal with that coming up next. And Bo, as you get ready for junior high school, I think you can take some electives, right? You get to choose some of your classes. Do you know if wood shop is one of those classes?
No, I don't know if it is. My sister would know the answer to that.
Okay. Well, do you think something like that would be of interest maybe sometime?
Yeah.
Yeah, why not, right? Do a little something different, right? Wood shop, I know they have it at some schools, but I'm not sure about all the different schools. So there's a program that we use here at Do the Math called Struggly. And what do you think you have to do with that?
Just keep like trying new things, or like
Just keep trying it, right? And when you have to keep trying and trying and trying, you're doing what? You're struggling, right? Okay, so that's the whole point of this whole thing. So the game that you're going to do today is quad, squad, sort. And you are going to, there are no directions with Struggly. That's the beautiful thing about it. You have to figure out what to do. So you and Cece head on over there and see if you can figure out what to do with the game.
All right. There are
And you don't
it's
need a pen for
yeah,
this
it's
one.
just,
You
you're
just use
just
your
going to
hand.
move stuff back and forth. Okay, so it looks to me like we're going to maybe touch this and decide if it is a positive or if it's a negative. What do you think? It says rectangle. That's the only instructions we have.
maybe if it's good, if it's a rectangle.
I think I like that idea. Okay, so what do you think? Is that a rectangle?
It's a square, but squares are considered a rectangle.
Okay, so what is the definition of a rectangle? How do we know that this is a rectangle?
The only difference is that a rectangle is a little bit longer.
Okay, that the two sets of sides don't have to be equal. Okay, let's go ahead and move it and see what happens.
See if it actually is.
Hey, all right, I like it. Okay, so next one, what do you think? Is that a rectangle or no?
No,
Why?
because it doesn't have two sets of parallel lines.
Well, this is parallel. That little arrows mean parallel, but
Right.
but what is wrong with that? There is something wrong with that.
The right angles are all.
They aren't right angles. You're exactly right. They're supposed to be right angles, but we've got 89s and 91s. Let's toss that card. I think that's a good idea. Okay, what do you think this time?
This one has has all the right angles, but this is 45 degrees.
Well, I think you're right about this
Yeah.
being a 90 degree and this a 90 degree.
And it's all
And
parallel.
this, right, and my arrows again say that it's parallel. So let's see what we think. What do you think?
I think it would be considered. 'Cause
Okay, let's go ahead and give it a try. Just because it's kind of sideways, maybe it's not a big deal. Okay, what do you think about that?
If this one's a right angle, all the rest of them look like that. And it's also both of them are, the sides are parallel.
Okay, so they're all the same and we've got one 90-degree angle. So you're thinking it's okay?
Because it has one, but all the others look exactly like it.
They all look like it. I wonder if they all are. But let's go ahead and give it a try. Okay. Yes or no?
No.
No, I would agree with you. What is that one called? Do you remember?
It's either a parallelogram or a kite.
Ah, true. Okay, so we've got the parallels, so we'll go ahead. But we'll go ahead and toss it. We know it's not a rectangle. Okay, what do you think?
It doesn't have any right angles.
There you go. Okay, so you're going to toss it?
Yeah.
Okay, I like it. Next.
This one has the right angles and the parallel lines, so it's good.
Okay, so that doesn't mean parallel. That means equal to.
Oh,
So
equal.
these sides are equal to each other. We have 90 degrees there.
And these ones are kind of like 90 because they look the same.
Okay, all right.
If you're looking at it that way, they both will go equal. And these
Right.
ones will
Well, and we also know that because that's 90 and that's 90, we know that those are going to end up being parallel. But that's okay. That's a story for another day. Okay.
So
So you think so?
yeah,
Okay. Oh, I think this one's pretty obvious.
it looks like a deformed triangle.
It kind of does.
could have been a rectangle at one time.
Maybe. It has some issues. What do these mean? These little dashed lines. What do all of those mean?
It means if you were to like fold it, it would be symmetrical.
Ah, perfect. Okay, I like it. So what do we think? Does that make it a rectangle if we can do it all of those ways?
It makes it a rectangle, but it's not because of the symmetrical. These two sides are both parallel, and these look like right angles, perfect right angles.
Okay.
So
Okay. And we know that if it could fold, that these are got to be the
right
same.
angles.
And okay, well, don't necessarily have to be right angles, but we're probably pretty close. Let's go ahead and see what you think. Okay.
All right, so we're going to give you one more, see if you can get to 10.
Okay.
Because this is your 10th one now.
What do you think?
no,
No, I think
these
you're right.
aren't right angles, and these
Right.
aren't parallel.
There you go. And all my sides are different, and all my angles are different.
There you go, nicely done. So here's what I want you to do. On this one, I want you to purposely put it in the wrong spot to see what the message would be.
Okay.
And this one's pretty obvious.
I think that one's pretty obvious. Oh,
Need to hit.
So there it is. So the beauty about that game is that it will help you along with it in case you get a little bit stuck, but you already knew about rectangles and squares and quadrilaterals and things like that. So nicely done, and I think you learned a little bit more about the angles and the equal sides and things also. So nicely done. We'll be back with more right after this. All right, we've come a long way, and now you need to decide how are you going to cut this, because obviously there's a couple ways you can do this.
The right way and the wrong way.
Yeah, well, at least two, right? So what goes through your mind? What do you have to do first, or how are you going to go about this?
When you get a log, or cant in this case, and you're trying to figure out how you're going to mill it and get the most merchantable amount of lumber out of it, is you got to look, see if there's any major defects that are going to affect what you're making out of it. Now, if this cant had a major defect, whether it had a major split that was very large coming through here, I could mill this in a pattern so that the whole defect went in one board, throw that one board away, so it doesn't affect every board in the cant.
Okay.
So we have a little bit of heart check here. All redwood does. It's nothing major, especially for fence boards. We're not building furniture grade stuff where that's going to be an issue. So what we're going to do to this is, since we are 17 that way, and we're 20 plus that way, we're going to cut a 12-inch cant out of here. So we'll probably, there'll be a cut line that's going to be down in here, and then we'll separate these two. I'll set this one aside, the remaining cant. We'll bring this one back to the mill, turn it 90 degrees so the 12-inch dimension is right and left, and then we'll just start slicing 7/8 boards off here, just like slicing bread. Right. And our target is to obviously keep making more of the 1 by 12 by 10 foot boards, and this remaining cant will knock it down to 6 inches and make 1 by 6 by 10 foot boards. We need 3,000 board foot. There's 10 boards in each, or 10 board foot in each board, so we're going to need 300 boards. So if you look over in the mill shed over there, you'll see 2 units of lumber already made. Each one of those has about 50 boards in them, and they're 500 board foot per unit. So we need to make 6 units that look the size and shape of those.
1 unit.
A unit is the banded compilation. Of course, I got stickers in there so they dry evenly of how it's transported to the end user.
All right, well, let's get cutting.
Very well.
All right, so Cam, we've got finished product. So we've got 2 different sizes here, obviously.
Right. These 2 units of lumber are for the same project over here. These boards are rough cut at 7/8, and they are sitting on 5/8 stickers for airflow. This is a louvered building I designed years ago. It's all the airflow every night and morning blows through there. It dries wood very efficiently, but you gotta let the airflow through there. On thicker material like this oak that I cut 3 months ago, because it's 3-inch thick, we had to go a lot thicker sticker because the stickers dictate how much air travels through there. And if you don't have enough airflow, you will get mold and you'll get irregular drying and the boards will warp, and pretty soon you'll cut the bands off and the thing will start moving like a potato chip. It'll look horrible. They're all banded, and this is how much they shrink in a couple months. These bands were like your car strings when I put them on there. As soon as that starts
you can
drying,
see how much that gives.
That's how much water has dried out of this material since I cut it.
So you're going to have to band them again for transport.
Yeah, I will cut these bands and reset them with a new crimp so they stay tightened together. Otherwise, bouncing down the road, they will start shifting and moving around. So you want to have it delivered. And if you look at the end view, this is all 6-inch boards, like on our closer stack there, and the second unit is all the 12-inch boards.
Well, we learned a lot about board foot, a lot about how you go from getting a piece of timber and then eventually getting it like this ready for market.
Right.
And for helping us, we would like to say thank you,
Oh, well, thank you.
for helping us to do the math. And that is it. We've got Cam from the Creston Sawmill. Well, we certainly did learn a lot that day from Cam. Certainly a pleasure to work with. And once again, thanks to Cam for inviting us out to Creston Sawmill and learning all of that about board foot and things like that. How are you doing?
Good.
You feeling pretty good?
Yeah.
Do you know what a prime number is?
Yeah, it's a number that is only able to be divided into by 1 in itself.
Do you know any prime numbers?
7, 2, 1, 3, 5, 13, 17, 23.
Hey, you know what? We're going to stop you right there because 23 is what? It's our favorite number here on Do
There
the
we
Math.
go. There-
It
yeah,
is a prime
your
number right
favorite
there. So
number.
you know 23 is our
Yeah,
big
yeah,
number here
yeah,
on
for
Do the
sure.
Math. Anyway, you ready to work with a prime number?
Yeah.
All right, head on over to the board.
You know, there was a little bit of a discussion around whether or not 1 is a prime number, but that's a story for another day.
Right.
What are we doing here?
So 13 is the prime number. You must use the 4, the 8, the 2, and the 6 in any order you want. You can add, subtract, multiply, divide, but you must use the 4, the 8, the 2, and the 6 to somehow come up with 13 as an answer.
Okay. Yeah, this is all you.
Hey, grab a marker and
Let's
go ahead
do
and
this.
start figuring stuff out.
So 8 plus 6 is 14. Divided by 2 would be 7. Plus 4 is 11, so not.
Okay.
8 times 4 is 32.
Okay.
Plus 2 is not 36, which
Okay, hey, I love this thinking. Keep going.
2 times. So if you add both those, that'd be 10, which wouldn't be good. 2 or 6 plus 2 is 8, and 4 plus 8 is 12.
Okay.
So 8 and 12 wouldn't really do anything. 6 plus 6 plus 4 is 10, which, and then 10, no.
So I think you're on a,
Yeah,
a
he's
really
on
good track.
track right there
Yeah,
with what he just
you're on
said.
a really good. You're on a roll with this idea. So let's go ahead. Maybe let's start like making some notes of what you're doing, just so that we can start to kind of slim down some ideas.
8 plus 4, I'm doing like adding them all.
Okay. All right.
And then would be 12, which then would, no, that wouldn't, I was thinking divided by 2, which
Okay.
would end up making it 12.
Well, so we can always go ahead and think about if we were to say divide, one of these by 2.
And then add.
Right. So we've got a lot of options. We've got a lot of things that we can do. I'm not convinced that that's necessarily going to help us a lot, But we do, the problem is that we have all of these even numbers. It's kind of like that problem we were working on before. We have all these even numbers and we need to get to an odd number. So how in the world are we going to get to an odd number from all of these evens?
So I was told that I have to use at least all of them once. Can I use them, like, if I have to use them at least once? Could I use, like, say, one of them twice?
Ooh, that's pretty good. He said at least once.
Very inquisitive, but you use every number once and only once.
Just one time. Okay. That was great, though. I love that. Okay. So, is there a way to get to an odd number if, say, we were to do some division, right? Or do some multiplication first, or some addition and then some division to maybe get us to an odd number?
Would you like a hint? What I would do is I would take any two numbers you want and add them and divide it by 2, because that is going to take an even number and cut it in half, and you might get an odd number somehow.
Yeah. So let's
try that.
Let's figure out what's going to get us to an odd number and divide when we divide by 2. So this one we added, that's 12 divided by 2. That's going to give us 6. So that's not going to do it.
And I know that 6 plus 8 would be 14, divided by 2 would just be 7, which
Would be 7, would give us an odd number, right? So that's a good one. So let's do that.
Which
So-
one, 7, what could you
So go ahead and let's write it out though. So because we've got to use them every one of them. So let's do an 8. 8 plus 6.
plus 6 is 14.
Okay.
Divided by 2 is 7.
Okay. So then 7. The only thing we haven't used so far is the 4.
What
So
thing would really help?
right. So that doesn't get us. That gets us to 11. But at least that gets us to a place where we're starting to see some odd numbers. Because up to this point we've only seen.
So maybe try the 6 and 4, because you've done 8 and 4. So try 6 and 4 and see what that adds up to, and go from there.
I'm trying to figure out how to get to 26 and then just divide it by 2 to get 13.
Oh, I see. That would be one way. The hint he gave us was, if we add 4 and 6, what do we get?
10
Divided by 2 is?
divided by 2 is 5.
And then what one haven't we used yet?
8, which would be adding them would make it 13.
There we go. So that's one way. I do like the idea of seeing, because that would get us to that even number, seeing if there's a way to get us to 13. Or to 26 and then divide by the 2. I like that as well.
There you go. Nicely done. Come on over, Bo. So that was a great way to solve that problem. And as Cece said, trying to get to 26 and then cut that thing in half. And there's probably another way to get to 13. There are probably 5 more different ways to get to 13. But you did some excellent work today, and you are now an ambassador for Do the Math. You know what that means?
I get to brag about that I was on the show.
Indeed, you do. You get to tell everybody about Do the Math, right? Because somebody's going to see your shirt, right? And they're going to go, hey, Bo, what's up with that Do the Math shirt? And you can tell them all about it, right? So I've got a couple of questions for you. Are you a master of this?
I am able to do them, yeah.
Excellent. Very good. So I've got a couple other questions for you. I might mix it up a little bit while we're sitting here. We'll see what you do with this here, smart guy. Did you learn a little something today?
Yeah.
Good. Did you have fun today?
Yeah.
That's the most important thing. Can you figure that out real quick? I'm going to give you 20 seconds.
I don't.
That's kind of
Maybe
an
not in
impossible
20
thing to do in
seconds.
20 seconds, isn't it?
Not impossible. It's just really hard to do.
Yeah, it is.
in 20 seconds.
Anyway, Bo, you keep working on that. Hey, until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, California Resources Corporation, Edison International, Center for Neural Skills, the Kern County Superintendent of Schools, Kern High School District, Panama Buena Vista Union School District, Tuolumne County Superintendent of Schools, and Valley Strong Credit Union, with additional production assistance provided by these supporters of education.